Hello. So last class we were looking at finding the number of integer solutions. So let us look at one more problem in previous class. So the question is find the number of integer solutions to the equation x1 plus x2 plus x3 equal to 28, where you have 3 less than or equal to x1 less than or equal to 9, and we have 0 less than or equal to x2 less than or equal to 8, and 7 less than or equal to x3 less than or equal to 70. So first let us start the equations with 0. So let us convert the integrals in the form, let us convert the intervals in the form 0 less than or equal to xi less than or equal to some number. ഇവിടെ 3ഉം 7ഉം ആണ് വരുന്നത്. നമുക്ക് ആദ്യം 0 തൊട്ടാക്കാം. So for that I will consider the variables x1 minus 3 and ഇവിടെ x3 minus 7 എടുക്കാം. So let me take y1 equal to x1 minus 3 and y2 is same as x2, and take y3 equal to x3 minus 7. Then the equation becomes, so you'll get x1 minus 3 plus x, okay, so it will be now in terms of y1. Okay, so x1 alla y1 plus 3 plus y2 plus y3 plus 7 equal to 28. So that is y1 plus y2 plus y3 equal to 18, and we'll have the conditions. So 0 less than or equal to y1 less than or equal to 6, then 0 less than or equal to y2 less than or equal to 8, and 0 less than or equal to y3 less than or equal to 10. Now let me define my universal set S to be the set of all non-negative integer solutions. അപ്പം നമുക്ക് solutions എന്ന് പറയുന്നത് y1 greater than or equal to 0, y2 greater than or equal to 0, y3 greater than or equal to 0 ആയിരിക്കും. And now together with that we will now define the properties. അപ്പം നമുക്ക് കണ്ടീഷൻസ് ഇതാണ്. എസ് എല്ലാം നോൺ നെഗറ്റീവ് ആയിട്ടുള്ള സൊല്യൂഷൻസ്. ദെൻ we need to find the number of integer solutions such that y1 is less than or equal to 6, y2 is less than or equal to 8, and y3 is less than or equal to 10. So നമ്മൾ properties define ചെയ്യുമ്പോൾ we will define the properties to be so x will possess a property, the given element y1, y2, y3 will possess the property p1 if y1 is greater than or equal to 7, അതുപോലെ y2 property 2 എന്ന് പറയുന്ന y2 greater than or equal to 9, and property 3 is y3 greater than or equal to 11. അപ്പോൾ ഇനി ഇത് നമ്മൾ ഇന്നലെ ചെയ്ത പ്രോബ്ലത്തിന് സിമിലർ ആയി. നമ്മൾ inequalities എല്ലാം 0 തുടങ്ങി സ്റ്റാർട്ട് ചെയ്യുക. So we will get this new equation. Now this is similar to what we have done yesterday. Okay, so let S equal to the set of all a1, a2, a3 such that a1 plus a2 plus a3 is equal to 18, and ai belongs to n plus. Now an element a1, a2, a3 belongs to S is said to possess property P1 if and only if. So the condition for P1 is A1 must be greater than or equal to 7 and P2 is A2 greater than or equal to 9 and P3 if and only if A3 is greater than or equal to 11. So now we need to find out the number of elements such that it possesses none of the properties P1, P2, P3. So therefore the required number of integer solutions so that will be equal to the number of elements in S that satisfies none of the properties. So that will be equal to E of 0. So E of 0 will be omega of 0 minus omega of 1 plus omega of 2. മൂന്ന് properties നമുക്ക് omega of 3 വരെ വരുള്ളൂ. So now let us find the values of omega of 0, 1 and omega of 2. So omega of 0 will be cardinality of S. So this is our equation y1 plus y2 plus y3 equal to 18. Cardinality of S will be n plus r minus 1 c n minus 1. So that will be 3 plus 18 minus 1 c n minus 1. So 2 value. So that will be equal to 20 c2. So we will get it as 190. Now let us find omega of 1. Omega of 1 will be omega of P1 plus omega of P2 plus omega of P3. We omega of P1 എടുക്കുമ്പോൾ you will get y1 plus y2 plus y3 equal to 18 such that y1 is greater than or equal to 7. So y1 minus 7 will be greater than or equal to 0. So you will get minus 7. So therefore omega of P1 will be 18 the place left 18 minus 7 vary. So this will be replaced by the new variable. So the number of integer solutions will be 18 minus 7. So 3 plus 18 minus 7 minus 1 c 2. അതുപോലെ omega of P2 എടുക്കുമ്പോൾ you have y2 greater than or equal to 9. അപ്പോൾ ഇവിടെ 18 minus 9 വരും. 3 plus 18 minus 9 minus 1 c2 plus 3 plus 18. Okay. Third property y3 greater than or equal to 11 ആണ്. അപ്പോൾ 18 minus 11 minus 1 c2 വരും. So that will be 18 minus 7 11 13. So 13 c2. So this will be 11 c2 and this will be 9 c2. So that will be equal to, okay, so you get 78 plus 55 plus 36. So the value will be equal to 160. Now let us find the value of omega of 2. So omega of 2 is omega of P1 P2 plus omega of P1 P3 plus omega of P2 P3. Okay, so P1 P2 വരുമ്പോൾ നമുക്ക് രണ്ട് കണ്ടീഷൻ വരും. y1 greater than or equal to 7 and y2 greater than or equal to 9. 3 plus 18 minus 7 വരും 18 minus 16. So n plus r minus 1 c n minus 1 plus c2 വരും. ഇനി p3 വരുന്ന y3 greater than or equal to 11. So p1 p3 എടുക്കുമ്പോൾ 3 plus 18 minus 11 plus 7 വരും. അപ്പോൾ 18 minus 1 c2 plus omega of p2 p3 എടുക്കുമ്പോൾ 18 minus 20 വരും. It is not possible. So omega of p2 p3 there are 0 elements. It satisfies that two properties. Okay. So we get 4c2 plus this will be 2c2. So that is equal to 6 plus 1. So we will get 7. Here omega of 3 എടുക്കുമ്പോൾ it is omega of p1 p2 p3. So that is not possible. Simultaneous ആയിട്ട് ഇത് മൂന്നും some possible. So that will be equal to 0. So therefore the required number of integer solutions will be, so that is equal to e of 0. So we will get so cardinality of s was 190. So 190 minus 169 plus 7 minus 0. So this will give the value of the number of integer solution. That will be equal to 28. So the required number of integer solutions will be